Very easy. So we're in chapter 19, and section 19.1 has to do with graphing data, which is something you do in 8th grade, so we're going to skip it all together. And we're going to go directly to 19.2, which is the measure of central tendency. Obviously some topic that is totally irrelevant to us, but that's perfectly okay. When we fill it in, we might know what it means. Well, that was good. I deleted that page too. Oh, excellent. What can I undo? Oh, I undid the delete. All right, what a deal. All right, so the first thing we have is a mean. And some people would use the word average. And the mean, we use an X bar for the mean. So if you look in your calculator, there's a key that has an X bar on it. That means the mean. And we're going to take the summation of the elements. And we're going to divide that by the number of the elements. So if I have 2, 3, 4, 5, 2, 3, 4, 5, then I'd say, well, the mean of those numbers would be 14 divided by 4, 4.5, 3.5, 3.5. And if I brought my calculator with me, which I can't because I left it in either Michigan or Connecticut, I could show you how to enter the 3, 4, 5 into your calculator and have it tell you what the mean is. Okay, the next guy is the median, and that's sort of like the thing that goes down the middle of the divided highway, the median. And so if I have 2, 3, 5 is my data, the guy in the middle is my median, so my median is 3. My average is, my mean would be 10 divided by 3, 3 1/3. So my mean is different than my median in that particular example. If I had 2, 3, 4, 5, and my median would be between the 3 and the 4, so it'd be 3.5. If I had 1, 2, 14, 14.2, 19, 37.8. Then my median would be in between those two, and my median would be 14.1. So if I have an odd number, my median is one of the element sets. If I have an even number of numbers, then my median is going to be halfway through whatever the two numbers are on either side. And for our last guy, we have the mode. And the mode is the number of which I have the most. And I could have more than one mode. So if my data set is 1, 2, 3, then my modes are 1, 2, and 3. Each of them have one guy. But if my data set was 1, 2, 2, 3, then my mode would be 2 because I have 2 of them. If my data set was 1, 1, 1, 1050, 3075, then my mode would be 1 because that's the guy I have the most of. I have more 1s than anybody else. Okay, so that's all there is. There ain't no more to that. And we'll look at problem number 2. 12 extension cords are measured from the depth of their rubber coating. Are measured for the depth of their rubber coatings. The measurements are in millimeters and are as follows. And what we're supposed to do is we're supposed to find the mean, the medium, and the mode. All right, so what I would do is I'd take the data set and line it up in order. So the smallest guy appears to be a 2.3, 2.3, and a 2.5, 2.8, 2.9, but there's another 2.8, so I have two 2.8s, and I have a 2.6 that I didn't put in. And I have another 2.8 because there's three of them. What a pain. Okay, 2.9, then it looks like I've got a 3.1 and a 3.4, 3.5, and a 4.8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Darn, there's 12 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's a 3.7 that I missed. Alright, so now I've got them all. So the easiest guy to do is mode, right? So we'll do him first. Mode is 2.8. And the medium is, it says 12. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it's halfway between 2.8 and 2.9, so it'd be 2.85. And now we need the mean, which means the average. So now I'd have to add them all together and divide by how many they are. And somebody going to do that for me real quick? I'm gonna do it differently because I'm gonna do it in my head. Okay, so I'm gonna assume that it's 3. Okay, so I'm gonna have a minus 0.7, a minus 1.2, a minus 1.6, a minus 1.8, a minus 2, a minus 2.2, a minus 2.2, a minus 1.8, a minus 1.3, a minus 0.6, positive 1.2. So I have a 1.2 difference between my guess, which was 3. I'm going to divide that by 12, and I'm going to get a 0.1. So my medium is going to be 3.1. Okay, so that's how I would do it in my head. Now, I really wouldn't do it in my head. What I would do is I would get out a calculator and I'd put the numbers in it, right? So, 2.1. It is 2.1? Yeah. You didn't get 2.1?
Unless I got something different.
What a
Or
hoser.
I forgot to add something.
Now, if you have a TI-36 calculator, you go third function, put it, second function, I think. Second function, put it in stat1 mode, and then enter the data, and then ask for the mean, and that would be the best thing to do. All right, so you're telling me I'm going to have to put it in my calculator because Dustin doesn't believe I'm right? Oh, what a bummer. 2.5, 2.6, 3 times 2.8, 2.9, 3.1, 4. I did?
Yeah.
Bummer. 3.1. But if I put 3.4 in twice, then I'm hosed. So I'd have to do it over again. So I like the way I did it in my head the first time because I came up with the right. Dustin, do I have the right answer or not at 3.1? 2.99? What a hoser. All right. Well, I'll go back to the original data set and put it in my calculator then. 2.3, 2.8, 3.4, 2.9, 4.8, 3.7, 3.1, 2.6, 2.8, 3.5, 2.5, 2.8 equals, divided by 12, 3.1. So, yeah, in order to do these types of problems, you will have to be able to use your calculator, not fat finger the keys over and over and over again. Okay. That was number, because they're so simple, I'm going to do even. You guys get to do the odd ones. The outputs of a 9-volt battery were measured as follows. And we want the medium, mode, and whatever. Okay, so the lowest guy was 8.8. Okay, so again, I'd arrange my numbers first in order. 8.8, 8.9, 90, 90, 90, 90, 4 of them. And then 91, 91. There's an 8.7 that I missed. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Darn, there's a 9.2 that I missed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so I've got them all. So first, again, we'll go with mode first because that's most obvious, and that'd be 9.0. There's 4 of them. And then medium, and I'm pronouncing it a little funny. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it'd be halfway between 90 and 90. And then we'd want to know the average. Okay, I'm going to assume the average is 90. So minus 0.3, minus 0.5, minus 0.6, minus 0.5, minus 0.4, minus 0.2, minus 0.2 divided by 10. So I'm going to have 9, I'm going to have 8. 8.98. Doing it in my head. So if I was going to do it on my calculator, 8.7 plus 8.8 plus 8.9 plus 4 times 9 plus 2 times 9.1 plus 9.2 equals divided by 10. 8. Well, I can divide by 10. But I'd rather just divide by 10 in my head, but that's okay. 8.98, which is exactly what I thought it was. Okay, good enough? Number 6. A machine is calibrated to cut hoses 15.7 inches long. Each day of a 24-hour work period, 100 hoses are measured. The number of hoses each day which do not meet the specification were. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 different guys. All right. So look at the mode first. And 9 wins. Does 9 win? Okay, so 9 wins. And I got to line them up. 1, 2, 4, 5, 5.
There's a 3 in there.
Is it 3? Yeah, I see it. 5, 5, 6, 6, 6, 6. I see a 7. I see an 8. I see another 8. I see 9, 9, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so 14 means I go in 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Median is 6. Alright, so now I need an average. X bar. Alright, alright, we'll assume that it's 6. I have minus 5, minus 9, minus 12, minus 14, minus 15, minus 16, minus 16, minus 15, minus 13, minus 11, minus 11, minus 8, minus 5, minus 2. So I got minus 2 divided by 14, plus the 6 that I assumed that it was. So that'd be 6 and 1, no, it'd be 5, because it's a negative guy. 5 and 6 sevenths. Alright, do we believe that? Let's see, where's my thingy here? Okay, do we believe 5 and 6 sevenths, or do I have to go and do a calculation here? No? Yes? Good. Alright, so we believe it's good. Alright, so that was 6. We'll move down to 10. Use the data from table 19.7 and find the median and mode. Do I have to find the average? No, I don't. Okay, so we'll do number 10. Table 19.7. Alright, so, oh bummer, look at that. So I'm on page 577, and I want to find the mode, and I want to find the median. Yeah, let's see, what do I think about mode? Is there anything more than 2? Looks like I have multiple modes. So it looks like I have a... Oh, now I got a message. So I got a 1 for my mode. I've got a 3. Got a 12. Oh, wait a minute. 21. There's 3 21s. I don't think there's anything else that have 3, right? So 21. Now I've got to line these guys up. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 25 of them. Okay, well, 25, that means the 13th one is the median, right? So let's see if I can get to the 13th one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 is the 13th one. Okay, so I'm done there. Is it really that simple? Yeah, it's really that simple. That's a, you're supposed to do number 19. Is number 19 difficult? The daily high temperature of Fahrenheit in Kansas City during the month of March are as follows. Find the medium, mode, and medium. So I guess we can do 19. Is it okay if I do 19? Not going to spoil anybody's day. That's the beeping because the battery's almost dead now. Is that good? Alright, so have temperature. I have frequency. That's how many times. 28, 1. 35, 2. 42, 8. 56, 12. Anybody believe this data is real? 67, 5. 75, 3. And we want the medium, the mean, the medium, and the mode. 56 for the mode. What do you think? Alright, so now we're going to find the medium. I come in 3. I come in 5. 56 is also the medium. Alright, well, I guess we'll have to use our calculator. 28 plus 2 times 35 plus 8 times 42 plus 12 times 56 plus 5 times 67 plus 3 times 75 equals. How many days are there in March? There's 20, 30. I only have 30 days here. There's 20, 31. You're right, 31 days. Divided by 31 equals. Oh, I know that's not right. I forgot to hit the equal sign before I divided. So I only divided the last guy by 31. Okay, so plus 3 times 31 equals. No, that won't do it for me. Bummer. What was the question before I do it again? 56, 56. So I counted it in and come up on 56. My mode is simple. There's 12 of them. He's the most. And then I came in and I came in and I ended up at 56 there. Okay, anybody got a good answer for the medium yet, or am I pushing keys again? 28 plus 2.
What was your original, was that 24,769?
I don't know. I didn't look at it. All that I know is that when I hit the answer key, oh, I think I'm hosed. I'm so hosed. And doing it again. One 666 divided by 31. 53.7, and then we'd say, well, you know, we only have two significant digits, so I'd go with 54 and say that that would be perfectly okay. All right, so that's enough for median mode and whatever.
7
You could call it, yeah, you can call it whatever you want. I mean, this is statistics. All math majors are statisticians. They all lie, right? Yeah. So now we're in 19.3, and we're going to discuss measure of dispersion. So if my data looks like that, we might call that a normal type curve. The data could look like this. What would we call that? So if we call this guy normal, we would call this the May-West curve. And of course you guys are way too young to know who May-West is. Anybody know who May-West is? The female that hung out with Fields in the 30s. No. This is also the curve of nuclear weapon byproducts. So xenon 140 is sitting there, and strontium 90 is sitting there, and those are the two. Xenon's not a problem for us. It's a problem for nuclear power plants because it's a poison. The strontium 90 is a problem for us because it attaches to our calcium. It replaces calcium atoms in our body and irradiates us. So during the height of the testing in the 50s, into the 60s of the open air nuclear testing going on, it was a strontium 90 that was the thing of most concern. And okay, well, that being the case, we have a thing called the range, and normally we're home on the range. So if we have 1, 2, 3, 4, 8, 1,304, well, whatever that number is, then my range would be the high guy minus the low guy. So my range would be 1,033 in that example. So that the range is something that would be easy to calculate. You want me to ask you the range. The other thing that we have is the standard deviation. S-T-A-N-D-A-R-D, standard deviation. And so the standard deviation is the square root of the data point minus the mean squared plus the data point minus the mean squared plus blah blah blah, as many as there are, the data point minus the mean squared divided by n minus 1. So that becomes a more interesting calculation to
what minus 1?
huh? N, the number of data points minus 1. Now your calculator, your TI-36 calculator does that automatically for you, and all your graphing calculators do it automatically for you. So if you knew where the function was and knew how to put the data set in your calculator, it would just tell you what it is. If you have to do it manually, then you're hose city again, trying to figure out how to do that. So this is called the sample standard deviation. And then there's another one, sigma x, which is the standard deviation. And that's going to be the square root of the summation x n minus x bar squared, which is just another way to write that whole thing, divided by n. So you have a sample standard deviation divided by n minus 1, and then you have a standard deviation divided by just n. And clearly, if you need those formulas on the test, then you're hosed because you haven't figured out how to make your calculator do it yet. Okay, so that would be a problem. Luckily, I have Excel up here, so I can do it in Excel, and it won't be a problem. So, let's see, what are we doing? 1, 5, 9, 15, 17, and 19. All right, so I'll start with number 2. So I have a data set of 1, 4, 5, 6, 7, 8, 9, 10. Notice that I don't have to ask you what the mean is of the data set if I want you to find a standard deviation, because you'd have to figure out what the mean is, and I don't have to ask it, right? Isn't that great? Oh, wonderful. And I want to find the range in the sample standard deviation rounded to the nearest hundredth. All right, so always for half credit, you'd put down the range. Right, if you're being asked for both, then the range is going to be 10 minus 1, 9. So that's the range. So that's obviously half credit. Then, in order to find the sample standard deviation, we need to know what the mean is. So I'm going to go with minus 4, minus 8. I'm going to guess 6. Yeah, I'm going to guess 6. So I've got 5, 10, 12, 13, 12, 10, 7, 7, 4, 0. So the 6 is my mean, unless somebody tells me it's not. Then I have to calculate 1 minus 6 squared, and 4 minus 6 squared, and 5 minus 6 squared, and 7 minus 6 squared, 8 minus 6 squared, 9 minus 6 squared, 10 minus 6 squared. All right, so I got 25, 4, 1, 1, 4, 9, 16. Right. Now the issue here is, can I see everything at the same time? Okay, so I need 2 1s and I need 2 9s. Everything else I only need 1 of, right? All right. So I'm going to want there's not a bar there, is there? So I want the square root. How many elements are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to divide by 9. I'm going to have a 25 plus a 25, because there's 2 of them, plus a 4, plus a 1, plus a 1, plus a 4, plus a 9, plus another 9, plus a 16. Okay, so I got 2 9s. Okay, so that's what I got. So that's what I'm going to do. 25 plus 25 plus 4, 8, 10 plus 18 plus 16 equals square root. Okay, so I got that number divided by the square root of 9, which is 3, divided by 3 equals. So this is going to be 3.2 what? 3.23. And it wanted it to the nearest hundredth. All right, so we're all set. So that is not the way I would do it.
The first
Huh?
25.
The first 25?
Yeah, did you only have one?
1, 2. I have two 25s because I have two data points of 1. And then I have two data points with 9 in it, so I have two 9s. I only did the calculation once, but I needed two of them because I have two data points of them.
Oh, okay.
Yeah. Because I was running out of room. So, but if I had an Excel spreadsheet, do I have an Excel? Yeah, I do have an Excel spreadsheet. I can put in numbers 1, 4, 5, 6, 7, 8, 9, 10. And then I could go and get the standard deviation guy. Equals ST, standard deviation. S. Yeah, there we go. And then I want to go boom, and then close parentheses, enter. Boom. 3.231789. Is that what I got? Yep, that's what I got. Round it off. Yep. So I'd use, if I wanted a standard deviation and I didn't want to make it get the wrong answer, I'd use an Excel spreadsheet. You can do the same thing in your graphing calculators. Does somebody have a TI 36 on them? Not the pro guy. But TI 36. And stamp on that. And then you get the solution to be pretty big. So I got a 1, yeah. Yeah, the TI-36 Pro is going to do it too. You can add the data set and it'll be there. And in fact, in the TI-36, the instruction, little itty bitty thing on your front cover tells you how to enter the data. If it's still, you still have the piece of paper there? Yeah. One side or the other will tell you how to enter the data to get that number. Okay, well now that I have this guy out, and I'm there, I'm done with this problem. That's cool. That was 2. We'll try a different problem. Is there a harder one? We'll try 11. Find the range of the sample and the sample standard deviation, 3 significant digits. Number 11. Oh, that's good. 47, 49, 55, 61, 62, 72, 81, 84, 84, 87, 91. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so our set must be right. Okay, so the range for half credit, 91 minus 47. 44. So the range is 44. Now, when you're doing total quality management type stuff, the range matters. So if you have an industrial setting and you have a huge range in some manufacturing process, that's not good. You don't want the pistons going into your car to have a 3-foot deviation range of sizes. You know, it's not a good thing. So a big range would be bad. Right, now, in order to calculate the standard deviation, we have to find the average, and so that probably means we should get out our calculator and do that. Okay, 47 plus 49 plus 55 plus 61 plus 62 plus 72, 81, 84, 84, 87, 91 equals, divided by, did we say 11? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 70.27. Now, I want 3 significant digits in my answer. So I'm going to take 70.2727 and decide exactly what I'm going to do. And I don't really know yet. All right, so now I'm going to look at, I want 47 minus 70.27 squared. I want 49 minus 70.27 squared. I want 55 minus 70.27 squared. I want 61 minus 70.27 squared. I want 72 minus 70.27 squared.
62.
I want, did I skip 62? 62 minus 70.27 squared. 81 minus 70.27 squared. 84 minus 70.27 squared, and I'm going to want 2 of those guys. 87 minus 70.27 squared. 91 minus 70.27. Have you figured out what a giant pain in the butt this is yet? You should probably have figured that out already, right? Yeah. So the chances of getting the right answer are slim and none, but we're going to do our best, right? I already messed it up. Five, 4, 1, 5, 4, 1.5. We want 3 significant digits, so we're going to keep 4. 49 minus 70.27 squared. 4, 5, 2, 4. 4, 5, 2.4. 55 minus 70.27 squared. 2332. 2332. 61 minus 70.27 equals squared 85, 9. Do we keep 9, 3? I guess not. 85, 9. 72 minus 70.27. 2.99. Oh, I don't like that. 3. I'd feel happier with something other than that. We'll keep it that way though. 62 minus 70.27. 76.0. Okay, 81 minus 70.27. 1151. $84 70.27 1885. $87 2799. 91 minus 70.27 squared 4297. Okay, so now we're going to add those guys up. So I have 4297 plus 279.9 plus 2 times 188.5 plus 115.1 plus 76 plus 3 plus 85.9 plus 233.2 plus 452.4 plus 541.5 equals. What are we dividing by? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We're dividing by 10. Dividing by 10 equals, and then we're taking the square root. 16.11. 3 significant digits, right? 16.1. SX equals 16.1. Okay, if we go back to our spreadsheet and we put in 47, 49, 88, 55, 61, 62, 72, 81, 84, 84, 87, 91, and then we go look for the standard deviation equals standard deviation, that guy. Boom. Oh, bummer, we didn't put a range in. What the heck? S T. Alright, there we go. Close parentheses. Boom. Boom. What in the world? 110? Oh, bummer. Where's the delete button? Alright, there we go. 16.1. Now we have 16.0816 and we have 16.105. So because I rounded off the way I did, I'm going to have a rounding error, but the three significant digits I still have 16.1. Okay. We'll do 19 and then we'll call it a day. How's that? Number 19. A ream of paper is labeled as containing 500 sheets. The sheets were counted in random samples, and we got the following results. And we want to find the range of the result. This is where the range needs to be small, right? So we want the range, which is the biggest guy, 508, minus the smallest guy, 483. So the range is going to be what? 13 plus 8, 21. So the range is 21. And then we're going to need the average so we can calculate the standard deviation. Okay. Not sure I can do that in my head. I probably could, but it's getting later in the day. Right? 483. What? You think you'd rather have 25? Okay, we'll go with 25. Plus 490 plus 493 plus. I think this is far-fetched. I think there's really closer to 500 in every single one. You'd have to be pretty daft to have a counting system that is this far off. If I can't do better than this and putting papers in something, I should go to China and have them do it, right? What we got? 10, 12. So my average is 499.17. 499.17. Why don't we use 499.2 in our calculation? Okay, so that's our plan. So I want 483 minus 499.2 squared. 490 minus 499.2 squared. 493. 499.2 squared. 496. 499.2 squared. 499.2 squared, and I want two of those guys. 501. You know, it probably would have been better just to do this subtraction in my head. and to write all this stuff down. 502 499.2 squared, 505 499.2 squared, 506 499.2 squared, and I want two of these guys, 508 499.2 squared. Alright, back to my calculator. This is 8.8, right? 8.8 squared. 77.44. 77.44. And this is 6.8. 6.8 squared. 46.24. 46.24. I suppose I could have just said, I could have taken that and said add 2 times 77.44, and then I wouldn't necessarily have to do it again, right? Plus 5.8 squared, 33.64, plus 2.8 squared, 784, plus 1.8 squared, 324, plus 2 times 0.2 squared, 0.04, plus 6. That's 3.2, 3.2, 3.2 squared, 1024, plus 6.2 squared, plus 9.2 squared, plus, now we're in trouble. Is that 16.2? It is. 16.2 squared equals, divided by how many? 12, so we divide by 11, equals square root. So I got S of x equals 3 significant digits, 764. 7.64. Back to my Excel spreadsheet. 483, 490, 493, 496, 499, 499, 501, 502, 505, 506, 508, 508, equal sign, ST, ohm, highlight those guys, put a parentheses there, boom, enter. Is that what I got? 7.83? 7484. Yeah, I rounded. So obviously there's some rounding going on someplace. Did I enter the data right?
You have
I did?
508s.
I have two 508s?
We keep 508s.
I'm supposed to have two 508s.
I got the 7.63. Yeah, I got the 7.63 too. And I didn't round anything.
Well, obviously 7.83 is correct no matter what you have in your calculator, unless I put the data in wrong. 80, yeah, I did. I put the data in wrong. This is an 83. Did I do anything else wrong? So there's an 83, 90, 93, 96, 99, 99, 101, 102, 105, 106. All right, so I got the data in right. 764. 764. Okay, so count's right. Excellent.
I'm sure mine doesn't.